My name is Anton Vinogradov, and I'm working on Apache Ignite for the last 6 years and spend a lot of time writing tests to make it better. I hope so. And today, I'd like to offer you to take a deep dive into Apache Ignite. And the goal of this session is to figure out how to check your changes that you make when you're developing the distributed storage. First of all, let's have a look at the toolset we have to do this. We have more than 50,000 tests using JUnit framework. We have a special self-developed framework called Compatibility, which is able to start any Ignite version. Benchmarks are written using Yardstick framework, also self-developed. It allows to measure performance of various Ignite component or module. And brand new framework called Ducktests will be presented during the session, but a little bit later. And as I told you before, we have thousands of JUnit tests, and let's figure out why. First of all, this test allows to start the cluster and communicate via Ignite API. It's easy to write and debug such tests. That's why they're so popular. They also executing right now executing on Ignite Team City on regular basis. The only problem is that they check cluster behavior inside single JVM, inside single computer. Anyway, it's pretty easy, as I saw before, it's pretty easy to write or update such test. And all you need is to download Ignite sources, create a test, inherit from one of abstract classes we prepared for you, and just write your code, then run it locally or using any CI you want. For example, let's have a look at the test. It checks that remove all feature works correctly even when concurrent node is when node concurrently started. Okay, let's start the node, stream some data, start 2 more nodes in parallel, remove all data during the concurrent start. Here we're just waiting for start to finish. And finally checking that cache is empty. This means that feature works, but it's important to understand that every node started during this test was started inside the same JVM. And we can also start more than one JVM in a single test. This will allow us to simulate an almost real cluster. Communication and serialization issues can be found and solved using this approach, but unfortunately, network issues can. Anyway, it's still easy to develop. All you need is to use JUnit again and just define its multi-JVM method of abstract class, return true. Second and subsequent node will be started inside another JVM. And here is an example. It verifies a simple case that we're able to connect IP version 6 nodes, even when one of them configured with IP version 4 address as a primary address. Okay, and let's start the node with IP version 4 address as a primary and regular IP version 6 node inside another JVM. Let's stream some data from first node to the both. And successful streaming means we pass the check. But again, keep in mind that second JVM we used is not equals to the second computer. And unfortunately, network issues can be checked at tests like this. Okay, we already able to start nodes inside different JVM during one test, but how about to start nodes of previously released version to compare them with the current? And compatibility framework able to do this. It allows us to cover upgrade and communication issues between different Ignite versions. For example, between sync client and server nodes. It's still quite simple to develop such tests. This test located at separate model called compatibility, so you should activate it before the development. And this abstract classes here is just to help you to write less. Okay, good compatibility framework usage example is an upgrade from old version to the new version when persistence is enabled. Here we can check. Here we can see we able to check upgrade is possible from every released version to the current. And let's start not of previous. Let's start previously released version, not with some post startup closure, which generates data. Let's just stop it, keeping the data at persistent storage. Then start not from the current sources of the current version, and successfully check that persistent data was not lost, tell us that test is successful. And the ability to start any released version allows us to perform any upgrade check. Okay, as you may see, everything before was about local testing, but we test in distributed storage. Some tests try to simulate the real clusters, but simulation is always just a simulation. But what if we have some tool able to start Ignite using the real cluster? And of course, we have it. Yardstick framework able to perform benchmarking using the real cluster, bare metal, server, or VMs doesn't matter. We may measure throughput and latency, as well as resources utilization. And as a result, we'll gain full visual record just like this. But the main problem here is that Yardstick is a benchmarking tool, not testing. And more, even latest Yardstick benchmark was written a long time ago. Yardstick now is used to check well-established benchmark set. It's just a convenient tool used to compare performance from version to version. No one writes new benchmark, only use existing ones. Anyway, let's have a look at the configuration example. And here you can see we can specify JVM options and select props, define server host, as the example, the local host, and drivers. Drivers are client nodes that perform separations and measure throughput and latency. We can define test parameters, and of course, benchmark tests, benchmark set we want to run. Okay, seems we discussed all tools we already have, and it's time to take stock. Okay, it's pretty easy to develop and debug using when you're writing a JUnit test. Compatibility framework allows you to debug tests, but with some limitations. The real cluster can be checked only by Yardstick framework, but as you remember, Yardstick is a benchmarking tool, not testing. Both compatibility framework and Yardstick are able to compare different versions of Ignite with some limitations. And compatibility framework also able to execute custom code on previous Ignite version. Okay, and seems it will be great to have some tool able to do everything we discussed before. And we created, we call it Ducktests because it's based on the tape library from the Kappa team. The tape is an orchestration library that allows us to execute commands on remote host via SSH. And we use it to start stop nodes and other automatization scenarios. So it looks to be a perfect tool for testing, benchmarking, proof of concepts, demos, and Ducktests are currently available at a feature branch called Ignite.tape. We almost ready to present it, to merge it, and all you need is to check out it and follow the reading. The test has built-in integration with Docker. This means you may use Docker as a test cluster while you developing or debugging your test. However, Keep in mind that Docker should not be used for any measurement because it still uses your single computer to emulate the real cluster. To perform the real measurement, you should build your real cluster. It can be based on bare metal or VMs. And Dockerfile we have for local runs, we discussed before, is a proper instruction of how to build your real cluster. Just follow the Dockerfile. We have two environments built the same way. As a result of that test execution, you gain reports similar to this. The report will show you how many tests have been checked and how long it took. Each test, in addition to status, also able to provide some data. For example, we may see the result of discovery test execution. It shows how fast cluster able to start and how fast another failure was detected. Okay, any version of Ignite can be checked as well as Ignite forks, binaries supported, and as well as compiled sources. And all you need is to locate them to the OPT directory. Let's have a look at a simple test. Here we just starting and stopping Ignite server node. Ducktests use parameter to execute command remotely via SSH. For example, it executes Ignite SSH to start the node. And we've got Ignite node. Systerm are able to stop this node, and we may send it. And everything seems to be simple, I think. We may also start two nodes. One of them may be the client. And we may specify versions we want to test. Forks are also allowed. Okay, let's start the node, sending Ignite SH command. Ignite successfully started. Let's start some application based on Ignite client. We can do this by executing Ignite SH with some trick. We started with a simple application as a main class. Instead of regular class, we used to start Ignite at the previous step when we just call Ignite SH. And we've got an application with Ignite client not inside. Let's check the code of this application. Here is it. And as a regular JUnit test, we may call some Ignite API. For example, we may perform some boot. At this line, the application writes a special price to Ignite log. Application start method on agent, where Python started, grabs remote Ignite log, waiting for this phrase. And once this phrase found, application considered it as start. This code allows just to wait for termination by Systerm, keeping Ignite alive. And at this line, the application writes to log that has been successfully finished. That's nothing bad happened. Okay, stopping the application. It's, as you may remember, it starts waiting for Systerm after boot happens. And so we will gain cluster with data after this step, and we even may test it or benchmark, but at this test, we will just stop it. Okay, after test finished, we gain cleared resources, empty servers, but by the way, that test allows you to forget about such cleanup. All servers will be empty after each test automatically. Other application also supported. We implemented services for Spark or and Zookeeper, and it's easy to start any other custom application if you know the command, able to execute it remotely. Okay, let's check one more case. Persistent upgrade test we implemented using the Ducktests. It checks whether it's possible to upgrade from the old Ignite version to the new one when persistent named it. And we already discussed this case in the compatibility framework section. This Java application used to fill and check cluster data. And when the check param gained from the Python is false, it generates data. And if it's true, it just checks the data. Just remember this param. Okay, and here's the orchestration Python file. We'll test every specified version. Let's start with creating some base configuration, which we will extend with version later. And for each version we defined before, just extending the configuration with its version. Setting correct check application parameter we discussed before, and starting service without removing the persistent data. No crash means test passed, but of course the check may be more explicit. In the same way, you can optimize, I think, any scenario you want. And finally, since we got a cool tool that allows us to write pretty simple tests and check them on a real cluster. If you need to perform fair measurement or check some Ignite feature in real environment, it's really a good idea to use Ducktests to do this. And of course, this doesn't mean you should not use other tools. For example, JUnit is still the best choice for test-driven development, and Yardstick is still best choice for synthetic benchmarking. But only Ducktests allows you to implement any testing scenario or benchmarking scenario you can ever imagine. And in short, Ducktests was created during the work on Ignite Enhancement Proposal 56, which we called Distributed Environment Test, where we solved more than 100 issues. It was also used and validated during the work on Ignite Enhancement Proposal 45, where we fixed and improved crash recovery. We also checked some other cases, for example, brand new snapshot creation and validation, sync line compatibility. This framework also, as I mentioned before, allows us to test any Ignite fork. And we tested Ignite Superb Edition, the fork we developed. Also, the framework helped us to measure real rebalance speed on a real cluster we have, comparing profit of each configuration automatically with ability to gain same result on each rerun, which was never previously possible. And what's next? The next step for us, the team who developed this framework, is to finish merge preparation and make it part of Apache Ignite. The next step for you, users or customers, it's just to start using it because it's extremely helpful, I think. First of all, you may check your deployment performance. You might check crash recovery cases at your cluster with your settings. This may shelter you from the troubles in future. I hope so. It's pretty easy to automate demos or proof of concept by Ducktests. You may use Ducktests to get rid of manual deployments in Ansible-like way. And I think it's that any other case you only able to imagine are also possible. Okay, thanks everyone for your attention. And if you have questions, you may ask now or just send me an email later.
Thank you, Anton. And let me check if I have questions. Does multi-JVM test allow to specify a class path for the forked JVM? It could allow to catch missing class definition issues.
Not class path as far as I remember, but you can set classes available for another JVM. Maybe classes not available, something like this.
So thank you, Anton. Thanks a lot.
Thank you.